Alright, let's talk about something that feels like it should be impossible. Concrete barges that actually float. It sounds like a contradiction, right? Concrete is one of the heaviest building materials we use, and yet, there are entire boats and massive barges made out of it, calmly drifting on rivers and harbors. How is that even possible? I know, concrete is heavy. If you've ever tried to move a concrete block, you know it's no joke. I'm talking crush your foot if you drop it heavy. It's the kind of material you'd expect to sink straight to the bottom of a lake. So how in the world can entire boats made of concrete glide across the water without sinking like a rock? It almost feels like magic, but it's really just clever engineering and a bit of physics. Here's the secret. It's all about how the concrete is used, not just what it's made of. The trick isn't in the material itself, but in the way it's shaped and designed to interact with water. Let me break it down. Imagine you have a solid block of concrete. That's going to sink, no question. But if you mold that same concrete into a hollow shape, like a boat hull, you're changing the game. Concrete itself is dense, yes, but when you shape it into a hollow structure like the hull of a barge, something cool happens. The overall density of the barge drops because you're including a lot of empty space inside. The barge isn't just a solid block, it's basically a shell with a big, empty space inside. That space is crucial. It's what allows the barge to float. That empty space is filled with air, and air is way less dense than water, or concrete. The air inside the hull acts like a built-in flotation device. Now here's the science bit, stay with me. This is where Archimedes' principle comes in, the same rule that lets giant steel ships float. For anything to float, it has to displace enough water to push back with a force equal to its weight. The more water it pushes aside, the more upward force it gets. Picture this, if you take a concrete barge and set it in water, it pushes water aside. The water pushes back, and if the barge is designed right, it stays on top. As long as the weight of the water pushed away is more than the barge's weight, it'll float. That's the magic formula. That's why ships, whether steel, wood, or concrete, are built with those big open hulls. It's all about maximizing the amount of water they displace. You might be wondering why even use concrete for a boat. It seems like an odd choice when there are lighter materials out there. Well, during times like World War II, steel was in short supply. Shipbuilders had to get creative. Engineers needed something strong, cheap, and easy to mold. Concrete fit the bill. It could be poured into almost any shape, and it was available in abundance. It doesn't rust, it's tough, and if you design it right, it can last for decades. Concrete is surprisingly durable in water, especially if it's reinforced and maintained. In fact, there are still concrete barges from the 1940s quietly floating in harbors around the world. Some have even been repurposed as docks or breakwaters. But there's a catch. Concrete barges have to be carefully engineered. It's not as simple as just pouring concrete into a boat shape and hoping for the best. The walls can't be too thin, or they'll crack. Concrete is strong under compression, but it can be brittle if not reinforced. Too thick, and you lose the floating magic. The barge becomes too heavy and it won't displace enough water to stay afloat. It's a balancing act, literally. Engineers have to calculate the perfect thickness and shape for the hull. Engineers use special mixes of concrete with additives to make it even stronger and lighter. Sometimes they'll use lightweight aggregates or even fibers to reinforce the structure. Sometimes tiny air bubbles are mixed in to help reduce weight without sacrificing strength. This technique is called aerating the concrete, and it's a clever way to make the material more buoyant. So next time you see a concrete barge, remember, it's not defying physics. It's a perfect example of how understanding science lets us do things that seem impossible at first glance. It's just using a clever bit of science and a lot of smart design. Every floating concrete barge is a testament to human ingenuity and problem solving. If you're ever building a boat, don't count concrete out. With the right design, it can be just as effective as traditional materials. With the right approach, you can float just about anything, even something as heavy as concrete. So next time you see one of these massive concrete vessels, you'll know the science behind the float, and maybe you'll see them in a whole new light.